This is Dr. Will Harrison, and Dr. Peter Dorrington. We've titled this Step Away, kind of semi-joking but semi-serious, Step Away from the CAD Station. A hands-on immersive approach to second year teaching in mechanical engineering design. So,
this is one of the many changes we've made to a module. So constantly trying to improve it, and just VR is something we've put in this last year.
And so we've called it an intervention. So why this intervention? Well, we had the opportunity to sort of bring in a bit more kind of immersive technology in terms of the design process. It's a novel intervention. We're going to talk a bit about some of the challenges and how we overcame them. We've done an initial survey. Again, so we'll talk about some of the findings from that survey and some of the reflections and some of the quotes and sort of feedback from the students as well. This was, I'd say, in addition to a very sort of successful module that was run last year by Will. He made a lot of changes, a lot of really good stuff going on, and we had the opportunity basically to try and sort of add a bit more hands-on approach to some of the design process, which is the chance we had. We had 196 students. We had quite a lot of students to try and involve in this VR intervention. And the groups were set a design brief to develop a concept through to a detailed sort of CAD design, so CAD being computer-aided design. And yeah, so that was basically the gist of why we were doing this. And really, it was an opportunity for us to address a more open-ended design problem. So generally, it's a bit easier to mark and to kind of assess sort of quite closed, constrained design briefs, but as we know, when you're actually working in industry, you're not necessarily going to get such a closed, tight brief. So we wanted to make something a little bit more open-ended, so the students could be a little bit more creative, give them more creative freedom, and also give them a chance to try some new approaches that they might be using when they get into industry, particularly as VR is starting to be used a lot more sort of in design engineering, mechanical engineering areas.
Yeah, so what I love about this module is, we're engineers and it's an engineering module, but being the design, there's that sort of creative side as well. So, we're very good at setting the assessments and setting up a design project that's all analytical, but we're just trying to get the engineers to switch their sort of creative side of their brain on, and really get creative. And that's kind of Peter's background helps a lot with that side of it, and this is an opportunity then to add another aspect of creativity and sort of really to get the students thinking in that way. Yeah,
because it's very easy, I think, often, engineers are brilliant problem solvers, and that's what we train to be. But actually, sometimes you just need to take a step back and say, okay, well, let's not go for the obvious solution necessarily. Let's kind of push the boundaries a little bit more. What could we do? How else could we do this? And that's what we've tried to do, really, with this intervention. Bit tongue-in-cheek there, but, CAD on a computer, that isn't design. CAD is a tool that enables design. So you're kind of that there. One of the issues we found, I found this when I was in industry as well, it's very easy to work on a design in CAD and you can lose the sense of scale, yeah? You don't quite know if you're working on something small or actually, in reality, is this product, device, whatever, machine, massive, yeah? So you can lose the sort of sense of scale. So what we did this year is to bring in the new brief. So the new brief was a human-powered taxi. So very open, okay. We did give them some specifications, what sort of weight of massive passengers it had to carry, what sort of distance it might go, that kind of stuff. So we did give them some guidelines to work towards.
One of the reasons we chose this as a sort of the design brief is it's something that's sort of human scale. So it is something that you can interact with. We're not designing a bridge that's hundreds of meters high. We're not designing something so small you can't see it. It's something that students can go and think about the designs. They can go and have a look at bikes or cars or things that are of a similar size and kind of, get an idea of scale, really get to sort of think about it. And then obviously it's an ideal size then for interacting with the VR. Again, if you had a 100-meter long bridge, it wouldn't be very exciting in VR just staring up at something. But this was just the right size. And it also adds that aspect with, it's an object that needs to be reasonably light, so it adds another aspect of design, and you've got to stay within a certain weight. So you kind of designing it to its light as possible, so it's going to be as efficient as possible.
And what we did was, so to really sort of start off, often you can have 200 students in a module, and that's a lot of students. They may not have met everyone on the course, by the time we get to the second year. So straight away, we did a problem definition, sort of idea generation session in groups. So we actually got them in their groups, randomly allocated. So straight away, rather than let them go off and try and have to sort it out, organise it, they're in the groups, they're working together, they know who they're working with. But then we did some brainstorming activities, yeah? So again, rather than, right, what's the solution? Let's go to CAD, we can create a cylinder, so let's make the cylinder, whatever. Get them thinking about the actual product. So think about the brief. It's as simple as, what's the worst possible velo taxi you could make, or human-powered taxi? Well, actually, it's going to be too heavy to turn. It's going to be too big to go through the streets. The wheels are going to fall off. Okay, what's the best you could do? Well, it's going to be lightweight. It's going to be solar-powered. You can charge your devices on it. Whatever. Yeah. So by doing this and getting the students to sort of do these sort of simple activities early on, they kind of converge somewhere in the middle to get a better designed solution. Okay, so that was one of the things we started off with. Another thing, again, won't talk too much about, but we got them in the workshop, yeah? We got them doing some hands-on stuff. So they did the brainstorming, we got them looking at some information, finding out specs, finding out what products on the market, etc., what people need. Then we got them in the workshop actually trying to sort of mock up some of their ideas very quickly, very crudely. Well, I say crudely, some of them came up with some quite nice designs actually. There's only a few hours, blue foam, but it just helps that physicality and that kind of design process. Won't dwell on this too much, but again, it's this, if you have a prototype, it raises questions that you might not think about if you're just sitting at the computer, yeah, and just kind of designing it straight on there. Okay, it provokes ideas, how is the configuration going to work? Where are the passengers going to be? Where is my transmission going to go? Etc. Okay? And then virtual reality was the third part, which we're going to focus on now. But again, it gives you that way of visualizing your physical object. Okay, yeah? So by actually being able to sit inside this kind of large scale human taxi, we had students putting chairs down, sitting there and sort of going, right, okay, can I actually, is my head going to hit the roof? Are the pedals going to actually reach here? Is my gearing going to fit? So it's all that kind of stuff that helped us.
Yeah, so we did a bit of research before we did this, set this setup, the VR session up. We had to find some software. Do we write our own software? We really thought it was easy to use. I mean, one of the problems with the CAD software is it's quite hard to use. Your simple tools are sort of cutting and extruding. So if you go straight to CAD, your design is going to be made of cuts and extrudes. And so something that's easy to use and intuitive. Intuitive, instant interaction. So yes, we don't want a big learning curve. It's a challenge for lots of students to get through in a short period of time. So something that's quick and easy to use.
Well, something else we mentioned was the empathic design. So we had Dana to the keynote this morning. It was great. Started talking about participatory design, yeah, and how important that was. And she was talking about working with, the actual students with designs they were doing. And again, it's that by trying to understand the scenario you're going to use this in. Obviously it's not in a real street with the real prototype, but hopefully it takes a student that extra step toward that, so they can view this, mechanical design with all its parts in the real scale. So the solution, so off the shelf, we use a solution called Gravity Sketch. Again, there was a solution there. It works pretty well. Let's try it out. Let's see what we can do with this. So we tried Gravity Sketch, which is basically a sort of collaborative design development tool. You're sketching in 3D. I think some of you probably tried the software out today, but that was our vehicle to actually try and to implement this. But the challenge we had.
So the challenge, admittedly, when we started this process, we thought, right, we'll introduce some physical prototyping, we'll introduce some virtual reality type prototyping, and we'll compare them. We're going to have about 180 students, so we can put 90 doing each, it'll be fine. As engineers, we don't have much interaction with ethics normally. I simulate bits of metal breaking. It's not normally, ethics aren't normally an issue, but for this, we were told, no, everyone has to have exactly the same opportunity. So then we were faced with having to put, ended up being 196 students through virtual reality. So they're split into groups. So they're groups of about 5 or 6. They had 33 groups. We also had to make it fair to everyone. Everyone had to do it at the same sort of time in the design process. So we couldn't just have something at the beginning and something at the end. So we had to have a short period of time in which we did this. We had to allow them enough time to do it. We've heard a lot about some of the earlier talks. Your first half an hour or so within your virtual environment, so a lot of wow factor, especially for those who hadn't used it before, and sort of just thinking, oh well, just being impressed with the environment before it becomes a learning tool. So we have to allow sufficient time. We haven't got a dedicated space to allow enough people to do it at once. In the end, we split it up into 4 groups of 9, so we had 2 sessions with 2 lots running after each other, so sort of 18. So 9 running concurrently, then another 9, and then another day we had 2 sets of 9 groups going through again. So it was a challenge. So I'll talk about the workflow as well when we put this in. So we didn't want to do it too early in the design process. We obviously had the brainstorming workshop for people to get ideas together. Then the students did the physical prototyping. We put the virtual reality sort of in the end of the concept generation. So they had a bit of an idea of where they wanted to go. Some of them had already had some CAD models put together, so they could import the CAD models into Gravity Sketch and extend them. Obviously, we don't want it too late in the design because Gravity Sketch is more of a sketching tool and not for the sort of detailed technical drawings. So we had to get all the students in that same, it's an 11-week module, so they had to be all within a week or 2 period around sort of weeks 4 or 5, I think it was in the end.
So we had some logistical fun, I think, is the
fun
term to use. But it works. It worked out well. I think.
Big shout out to Mark Holmes who helped us.
Yes,
and his team of demonstrators helping out set up the place.
Absolutely, because we had, like I said, have 9 sets going at once. It was quite quite impressive. From there, what they did. Okay, so data collection. Obviously, we wanted to do this, but we wanted to see, okay, what can we learn from this intervention? So we have mid-module feedback and end-of-module feedback anyway for each of our modules, to make sure we keep progressing and improving what we do and learn. But what we did as well, we created a voluntary online survey, pre and post-intervention. Pre-intervention, we had 77 students out of nearly 200, and we had 58 after. Students who completed both the pre and post, we had 36, so 18% of the cohort, which, it's not bad, I think, actually, for student sort of completion. And I've heard people saying it gets sort of 6 sometimes from the modules doing these kind of things. So, yeah, so I think that's not too bad, actually. We did bribe them with some Amazon vouchers and various things to try and help them fill them in. But anyway, so we also carried out some mini interviews as well during the activities and the focus group at the end. And in their final reports, they did a short reflective report. So
we gave them dictaphones during the session so they could record their thoughts as they went along. And that was all post-transcribed.
Mm-hmm. So here you go, you can just see a very kind of quick montage of the sort of sessions there. So we had them in their groups. What we tried to encourage the person actually in the VR environments, to talk about what they were doing as they were doing it, and the groups sort of could see it on the screen and sort of interacted too. We'll come to some of the findings on that and improvements after, but
what we tried to encourage them to do is sort of go and do a quick 10 minutes to start with, and then rotate around, and then go in for each of the 6 group members have to go, and then go back again the second time, just so the first person can then learn. They're really much the guinea pig, just seeing what the software can do, and then as they go around the second time they have a go, they really can start doing some really good drawings, and they know what they're doing then, and everyone helping each other, showing them what they learned, taking notes for the design purposes, and yeah, I think it's worked well. They seem to enjoy it anyway.
And to give you an idea of sort of output from this, it's all very good and quite exciting, but how did we get the students to kind of use this? Well, here's just an example.
It's one of the wackier designs we got, but I like it. It shows straight through the process from, they made a simple foam model, nothing too technical there, just sticking a bit of foam together. They had a small CAD model, a sort of very basic CAD model before taking into Gravity Sketch, which is on the top right there, but they put a seat like a normal chair down while in the virtual environment. You know, they can manipulate the vehicle around them, so they actually feel like they're sitting in the driver's seat or sitting in the passenger seat, and you know, they can get a view out, you know, see what it'd be like actually to be in that design, and then, you know, annotate the design, and then they go on bottom right, and they go back to the CAD screen, and they know what they want to do then, and they can put some detailed drawings together, and finally, yeah, technical drawings.
And again, in that virtual space, you know, they were sitting there, and they were able to actually sort of measure out physically what the dimensions were going to be, sketch them down, note them. And actually some groups had the CAD, had SolidWorks on the laptop, and they were kind of changing things as well as they went, sort of one of the groups. But yeah, it's giving them those dimensions and then making, so whatever their solution is at the end, it's, you know, it's more realistic. Again, so just some examples here, you can see sort of on the bottom, as you're looking at it, bottom right. Okay, so that's a CAD model that's come in, but again, they can sort of sit in, they can get the idea of the space. These are just some of the examples they came up with.
Within Gravity Sketch, you also get the opportunity to put the mannequins in, so you can, you know, grab them, put them in. You know, the mannequins on the bottom right, they look quite happy. But yeah, they can all be manipulated around, and, you know, to see if, you know, is the seat going to be wide enough? They look at anthropometric data to see if the seat's going to be big enough, but then they can actually put the mannequins in and see what it'd be like.
We should say as well, actually, obviously large complex design, but what we do is, because the groups of 5, you'll have one person working on the transmission, one person working on the bodywork, one person working on the chassis. Yeah, so when they're actually in the VR environment, they've got an element to focus on, so then they can redesign their part. When it comes into CAD, they do finite analysis, etc., etc. But yeah, so it just helps them explore that in that space. Okay, so now we'll run through fairly quickly some of the data that we've had from this, from the participants. Okay, so
yeah, we did the online survey before and after. As we said, it was voluntary. So just a comparison of some of the same questions before and after. So the first one was, do the students view CAD software as an enabler for, or how useful it was for problem solving? Mm-hmm. So, as you can see, before the intervention, they all thought CAD was, you know, great for problem solving, but afterwards, okay, still more people thought it was useful in terms of problem solving than not, but there was a slight shift towards people thinking CAD was less useful after doing the design in the VR environment. Another question we asked is which one's this one?
So
yeah, how useful is VR in terms of problem solving? So you can see before, quite a lot of people hadn't used the VR. Afterwards, yeah, look, I mean, as you can see the results, people thought it was, you know, very useful or a major enabler for problem solving. Of those who hadn't used it before, you can see, you know, everyone thought it was a useful tool for the design process.
okay, yeah. So again, looked at things like, you know, what confidence you have in successfully being able to create your concept designs using virtual reality. I mean, we looked at the physical prototyping too as well, and other modes of creativity, but again, focused on VR today. Yeah, so again, you know, a lot hadn't used it before, but actually having, you know, followed this invention again, you know, there's quite a bit of, they found it easy to use, fairly intuitive, which is good. So that's a good sign. Of those who hadn't used it before. So again, sort of, yeah.
On the whole, again, quite a positive experience. People, yeah.
Again, in being able to modify your design. So before and after, again, this very easy to use post-intervention, which is good. That's what we want. We want to see them be able to change it, but to modify it and iterate very quickly. So that fail fast and sort of learn quickly kind of approach, yeah? So fail in the virtual rather than cutting material or making it and actually get the solution. Now, those who hadn't used VR before, again, well, great. They found it very easy to use, and that's in sort of a 2-hour session as a group. So, you know, we're looking to give them a bit more time in future so they can actually get over that initial kind of excitement, if you like, and then really get to grips with it. Manipulate. I'm going to go through some of these a bit quicker now because time. But yeah, you know, if you want to ask us more about these after, please do. Manipulate, moving the parts and so on. Again, quite high in the VR.
Again, those people who haven't used it before, you know, find it easy to use.
Bit optimistic here with the slides. Again, visualizing which is good. We wanted that. We wanted increased visualization. Again, we thought that would happen, but actually, you know, the data helps show that. And again, easy to use. And
so this one for enthusiasm for using virtual reality as a prototyping tool. So those who thought it was, or were highly enthusiastic about using it, remained about the same, but actually, post-intervention, there's a few people who are less enthusiastic than they were before. So this involves, you know, we need to look into the feedback a bit more to find out why this is.
So here's just some of the feedback we pulled from the end of module feedback. Again, you can read some of those in there, but
so a lot of it, you know, reasonably positive. You know, some of the main comments we've had is about being able to use the virtual reality more during the module, and also being able to use it at the same time. So originally it was, you know, for this time it was just one person doing it and everyone else, you know, taking notes and helping out. But one of the sort of overwhelming comments was it'd be useful if everyone could go in and be in the same virtual environment, modifying at the same time. So I think it's something we're going to add in for next year.
I think, you know, because we've got good feedback with the company, and they are developing that for next January, hopefully. So we will have that feature then in there too. So that's pretty handy. I'm not going to read all of these, okay. But again,
this is unedited thoughts from this is again from the online survey. This is just about the VR. So again, just sort of cherry picking some of the comments. It's all about having more space, being able to use the equipment. So we had a dedicated space set up in just for a one-off workshop. We have now got a space where students can rent out the equipment or borrow the equipment and go back and then do some more of this in their own time.
And things like putting the environment around the taxis. Actually, we did go and do some photogrammetry. We went and scanned an area in Swansea, like a pedestrian type area. But again, it was just time. I think probably over-optimistic to try and get that in there. But now, from what we've learned, actually, okay, let's get that in there. We can do that. And again, the software will enable that in the future. Okay, yeah, some more there as well. Yeah, the usual thing. We want to choose our own groups. But
yeah, this is just general feedback about the
group
module.
Work. Yeah, fun module. I like that one. That's good. But anyway, yeah, there are loads of self-directed learning. That was nice as well, actually, to hear about some of that. That's what we wanted to kind of create. We wanted them to get in there and kind of, you know, learning by doing as well. So
one of the things we tried to do is put some online tutorials, so some videos, so the students could learn about the how to use the software beforehand. But yeah, inherently not that many did. But I think if we then went back for a second session, people would probably, after having played with it, they would have then gone and looked at some of the online tutorials before doing a second session.
Almost get them hooked early on, and then they'll want to go back and learn a bit more. So yeah, conclusions. Well, yeah, we've mentioned that they viewed the CAD as maybe a bit of a barrier to creativity after the intervention, so that's something we'd like to explore a bit more. They were confident in using the VR fairly quickly, actually. It was, you know, quite surprised how quickly they picked it up to visualise, to create their designs. Again, yeah, I think it's fair. We feel it improved the creativity.
Yeah, so from feedback and, you know, from the poll results and just generally from what they're telling us, you know, creativity improves. And also, I mean, they really enjoyed the process, so it's always a big plus.
Yeah. Yeah, future works we mentioned. So one of the big parts of the feedback was they wanted to actually work together in a space, which, you know, makes sense. They're all immersive, they're all engaged, so that's great. So that's something we're looking to do next time now. Introduce it earlier as well. So, you know, maybe perhaps even before the prototyping, physical prototyping. Let's get it after the brainstorming. They get in there, they very quickly kind of create these sort of shapes and designs, and perhaps a bit of CAD, and then perhaps back in. It could be an iterative cycle if we can manage to squeeze that in.
So we could formally introduce it earlier, and then it would allow students to then do some in their own time. Now they've got the space available to them.
And arguably they can fail kind of quicker, if you like, in this sort of virtual world than, say, a CAD model where they've got to, you know, be a bit more geometric with the model, you know, be a bit constrained with what they're trying to do and make sure it's sort of the right size, the right scale. They can very quickly do it, undo it, etc.
You can invest a lot of time in a CAD model, and then if you decide something doesn't work, it's quite hard to then just, you know, delete everything you've spent weeks drawing. But in this with the Gravity sketch, it's so quickly to draw something new that there's not that investment in it, so people will be probably more readily available just to scrap a design and do something new. Finally, that's it. So if anyone's got any questions?
Thanks, Will, Peter. Any questions?
You were talking about collaborative working around a design. HoloLens holds out great promise for that kind of thing. I don't know if you looked at that kind of technology, because that's...
Yeah, the sort of augmented reality, yeah. I think...
With big multiple number of people wearing HoloLens and working.
I've seen some of that. Again, I think we're open to anything that's going to improve the student experience. So at the moment, this seems to work nicely with the virtual environment, the drawing. But I think what that might be very good at, thinking ahead, might be as if they've designed their almost sort of more detailed product, prototype. Then you could almost put that in the environment, in a real environment with the augmented reality. That might be quite a nice step forward. So yeah, I don't know what you think, Will, but I think it would be an extra thing in the future.
Yeah, that's definitely worth thinking about.
What I wanted to know, because that was coming from the students, what they wanted to do, was there anything else that they wanted technology to do that maybe technology can't do at the moment?
Yes.
That's quite interesting.
Yeah,
What else they want to do?
definitely. I think because if you're designing in CAD, it's very, prescriptive might be the wrong word, but you've got to be maybe a good CAD user to get some really interesting sort of more of the difficult shapes and rather than extruding circles, so maybe they don't have those skills yet. So actually, it's great using the virtual reality, but they'd almost like to be able to take that directly straight back into the CAD package, into SolidWorks. But obviously, you're dealing with different kind of surfaces and all kind of. So that's one thing they wanted. That's what they wanted. But actually, you can, some we've realised since, you can almost take those surfaces and then import them into the CAD software and then create surfaces from them. So it's not, the nirvana that they want, but it's that step nearer. Yeah.
It's almost as if the CAD software's got to catch up with the VR, because it's all surface-based modelling within the virtual environment. The CAD software's... There are programs like Rhino which are surface-based. It's not so common. I think with things like 3D printing coming in with all sorts of shapes, then there's a more of a surface-based modelling is becoming more popular.
One really quick one, the last thing. So you've got some free licenses. Did you feed back to the people who gave you those licenses what your findings were, and did you share your learnings with them?
Yes, we have done. Yeah, absolutely. Yeah, we've got they're a small startup, been very open to kind of discuss collaboration. So yeah, absolutely not a problem. We've given them sort of only like bullet points in an email. It's been nothing, but they've had feedback. And they came today, so we discussed things. So,
yeah, and hopefully we're going to collaborate more in the future. They seem quite keen on what we're doing with feeding back, so they've got working out nicely. 5 universities, they have the centres of excellence now to develop this. They've been, we're one of them now as well, so that's helpful.
Yeah. Okay, slightly past 2 questions. When you say create, are they physically changing the shape of their... Are they physically changing the shape of their vehicle and is it able to react that quickly? What they're doing? You keep saying about creating, but is it?
Oh yeah, so it's literally like 3D paint. So it's like you can draw. You're literally drawing in 3D and creating kind of the surfaces and the outside and the main points and what have you. So it's literally like 3D paint, if that makes sense, with different kind of tools. Yes, absolutely. It is. Again, coming back to the CAD idea, it is a creative tool. So we're kind of blurring the boundaries a little bit, coming from an engineering point of view, but just trying to bring that creativity in as well. So I don't know if it fully replace CAD ever, but it's that step.
No, it's definitely not a substitute for CAD. You're not going to get your dimensional tolerance that you're going to get from your CAD drawing, but it is a nice little tool for the sketching.
The reason I would ask that is because outside engineering, there might be lots of application in which you want to create and edit and do in 3D and in virtual reality, where CAD is developed.
Yep.
And I guess that's what...
Absolutely. If you talk to the Gravity Sketch company, they're doing stuff with artists and installation work and all kinds of stuff. So absolutely, yeah.
Can I ask a question? With getting more and more one person involved in the thing at once, going up to potentially 6, I can see that if you've got 6 students all trying to work on the same design, it could be complete chaos. There could be tangled cables and hitting each other and things. Has anyone tried that to see what some of the issues are, how well it works, whether there's a limit, whether you need to have one controller and 4 or 5 observers, something like that?
My initial thinking, jumping after, my initial thinking is, what we learned today actually is a lot of the sort of pro users, designers, actually sit down and do the creating. So actually, if we got them sitting down, maybe with a nice radius, so they're not going to hit each other, that might be a solution actually. So that's my thinking. I don't know if you-
Yeah, I mean, you can do it desk-based because you can, in the virtual environment, pull your design around. You don't really necessarily have to walk around it. You can pull it towards you. So yeah, we could have a row of six PCs in a row. Everyone's got their headset on and working it on themselves. And they'll have to, obviously have to communicate. You know, you could work on their communication skills a bit, maybe.
I would suggest before you do it with real students to try it with pilot group first, just to check that you don't end up hitting each other.
We certainly won't be having them standing up together anyway, that's for sure. I mean, they're working in groups of 6, so one person was doing the designing with the other people all around. We had a technical demonstrator or a member of staff with them as well. Obviously, we asked their group mates just to help them out, make sure they don't walk into a wall or walk into a desk, which some students did. Some thought it was a bit of a game to make their friends walk into something. Or,
But yeah, I think I like the idea of maybe 2 editing at a time, and then the other 4 observing or something. That's good.
Do we have any other questions? No? In that case,